Good morning, students. How are you all? Welcome to Sunset Tutorials. Okay, I hope you are all doing good. In my previous video, I have discussed the class 9th quadrilateral chapter. In that, the starting whatever the 8.1, 8.2, 8.3, 8.4, 5, 6, 7. So 7 theorems I have discussed. So in this video, I will talk about the midpoint theorem, which is one of the very important theorem in 9th standard. That is midpoint theorem. Okay, we will have the proof for this theorem. So midpoint theorem is based on a triangle. So it is applied to one triangle in which we will see directly. We will see the statement first, then we will go through the explanation. Statement of midpoint theorem. What is midpoint theorem? ಏನು ಹೇಳ್ತದೆ midpoint theorem statement? ಏನು ಯಾವುದ್ರ ಬಗ್ಗೆ ಮಾತಾಡ್ತದಪ್ಪ ಅಂತಂದ್ರೆ, see the line segment joining the midpoints of two sides of a triangle, is parallel to third side. ಸೊ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, ಒಂದು ಟ್ರಯಾಂಗಲ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಆ ಟ್ರಯಾಂಗಲ್ ಒಳಗಡೆ ನಾವು ಒಂದು ಲೈನ್ ಡ್ರಾ ಮಾಡಿದ್ವಿ. ಯಾವ ರೀತಿ ಲೈನ್ ಡ್ರಾ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, ಇಟ್ ಶುಡ್ ಬಿ ಜಾಯ್ನಿಂಗ್ ದ ಮಿಡ್ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ಎನಿ ಟೂ ಸೈಡ್ಸ್, ದೆನ್ ಇಟ್ ಈಸ್ ಪ್ಯಾರಲಲ್ ಟು ದ ಥರ್ಡ್ ಸೈಡ್. ಸೊ ಫಾರ್ ಸಪೋಸ್ ಇಲ್ಲಿ ನೋಡೋದಾದ್ರೆ ಈ ರೀತಿ ಒಂದು ಟ್ರಯಾಂಗಲ್ ಇದೆ ಅಂತಂದ್ರೆ, ಓಕೆ, we have to take triangle here ABC. So let us consider that this D is a midpoint of AB and E is midpoint of AC. So join this. So this DE is parallel to BC. If it is joining the midpoints D and E of AB and AC respectively, then it is DE is parallel to BC. Also this DE is half of the side BC. So here let us prove this given, okay, whatever we are right, given a triangle ABC with D and E are midpoints of sides AB and AC respectively. So ಇಲ್ಲೇನು, ಸೊ ನಮಗೆ ಒಂದು ಟ್ರಯಾಂಗಲ್ ಕೊಟ್ಟಾರ, they have been given a triangle and we need to prove that, and also they have given that D and E are the midpoints. D and E are the midpoints of the triangle ABC. D and E are the midpoints of the sides AB and AC. So here to prove, what we need to prove is we need to prove that DE is parallel to BC. DE is parallel to BC ಅಂತ ತೋರಿಸ್ಬೇಕು, ಮತ್ತೆ ಈ DE ಏನೈತಲ್ಲ half of BC ಅಂತ ತೋರಿಸ್ಬೇಕು. ಸರಿನಾ? ಸೊ ಇಲ್ಲಿ the triangle has been given and there's the midpoint. This we need to prove. So to prove this we need certain construction. Let us construct that. That is a small construction we will have. Small construction. What is that construction means? Let extend or produce the line DE to F such that DE is equals to EF and join FC. So here what we need to do, DE na extend ಮಾಡಬೇಕು. ಯಾವ ರೀತಿ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಬೇಕು? ಇದು DE ನ ಯಾವ ರೀತಿ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, DE must be equal to EF. ಹೌದಾ? ಆಮೇಲೆ EFC ಜಾಯಿನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. ಸರಿನಾ? So here DE must be equal to EF by construction. Now we will just have the proof for this. Okay students, now we shall have the proof for the midpoint theorem. So we have the statement and we have the given data and we have seen the what to prove and we have made a small construction. Now we shall have the proof. I will consider these two triangles, that is triangle ADE and triangle CFE. Okay, I will consider these two triangles. In these two triangles, what all the things I can have to prove these two triangles are congruent? I may prove it by SAS, I may prove it by SSS, I may prove it by AAA, that is angle, or else here RHS is not possible because none of the triangles are the right angle triangles. Other than the RHS, I can prove it. Let us consider, that is in a triangle ADE and triangle CFE. See, it is already been given that AE is equals to EC because E is midpoint. E is midpoint of AC. It is been already given. ಕೊಟ್ಬಿಟ್ಟಾರ ಅದನ್ನ ಆಲ್ರೆಡಿ, ಹೌದಾ? ಸರಿ, ಇಲ್ಲಿ ಮತ್ತೇನು ತಗೋಬಹುದು ನಾನು? ಆಂಗಲ್ AED is equals to angle CEF ತಗೋಬಹುದು. ಯಾಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್? ಅದೇನಾಗುತ್ತೆ, ವರ್ಟಿಕಲಿ ಅಪೋಸಿಟ್ ಆಂಗಲ್ಸ್ ಆಗ್ತವೆ. ಸರಿ, ಅದೇ ರೀತಿ ಇನ್ನೊಂದು ಸೈಡ್ ಅನ್ನ ತಗೋಬಹುದು ನಾನು, ಏನಂತಂದ್ರೆ DE ಈಕ್ವಲ್ ಟು EF ತಗೋಬಹುದು. ಯಾಕೆ? ನಾವು ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಮಾಡ್ಕೊಂಡಿವಿ ಆ ರೀತಿ, DE ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ EF ತನ. ಸೊ construction. So now it is construction. By construction it is been DE is equals to EF. So see here, by looking here we can say that the two sides and an included angle of one triangle are equal to two sides and an included angle of another triangle. Then the statement of SAS criteria says that if the two sides and included angle of one triangle are equal to two sides and included angle of the another triangle, then it is the two triangles are congruent. Hence we can by SAS congruency rule, I can say that triangle ADE is congruent to triangle CFE. Okay, we got the triangle are congruent, but still our intention is to prove that DE is parallel to BC and we need to prove that DE is half of BC. Now let us consider by anyhow we have proved the triangles are congruent. By CPCT we can take the corresponding parts equal. So that is, I will take here angle ADE. Now angle ADE is equals to angle CFE by CPCT, that is corresponding parts of congruent triangles. ಇಲ್ಲಿ corresponding parts of congruent triangles ಪ್ರಕಾರ ಏನು ಬರ್ತದೆ, angle DE equal to CFE ಬರ್ತದೆ. ಸರಿ, ಹಾಗಾದ್ರೆ but angle ADE and angle CFE are congruent, angle ADE and angle CFE are alternate angles. Students, see here, these are alternate angles. See, these two angles are alternate angles and we are getting them equal. If the pair of alternate angles are equal, then the lines are parallel. This we get it as this AD parallel to okay CF. AD is parallel to CF. We will get this implies again AB is parallel to CF. Again we get that BD is parallel to CF. So we get BD is parallel to CF. Let it consider equation number 1. Now also by CPCT, what we can say that also by CPCT I can say this AD is equals to CF. AD is equals to CF. This implies BD is equals to CF, students. Because, why? Because we have AD is equals to BD. AD is equals to BD. Okay, so let it be equation 1. From 1 and 2, what we can say? Look at here. Here we got a BD is parallel to CF. Here we got BD equal to CF. If in a quadrilateral, one pair of opposite side is parallel and equal 100%, that quadrilateral is parallelogram. This implies this BDFC must be is a parallelogram. Okay, parallelogram. If it is parallelogram, students, then DF must be equal to, DF must be parallel to BC. DF must be parallel to DC. This implies DF must be parallel to BC, but this implies this implies DE also parallel to BC, because and DE is half of BC. DE is half of BC because see, D, E and F are collinear points. So this is the statement on proof of the midpoint theorem. The midpoint theorem, what it states: the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and it is the half of the third side. So this is how the proof of the midpoint theorem comes.